about something like this? Two equal-length springs are nested together in order to form a shock absorber. If it is designed to arrest the motion of a 2-kilogram mass that is dropped 0.5 above the top of the spring from an at-rest position in the maximum compression. 0.2, determine the required stiffness of the inner spring if the outer spring is stiffness of blah, blah, blah. Oh, my cow. Is this an energy problem? Yeah, because it's got springs in it. No, that's not the reason. Okay. Is it a time spanner?
Yes.
Yes, okay. Do you care how long it takes to do this? No. Can you find the energies in and out of all of the things that are acting on it? Well, let's make a list. Let's see, you've got gravity. You've got potential, not worried about gravity. You've got springs. Are you worried about springs? No, you got potential for that. No, no. How about the normal force between, eventually the orange guy is going to fall down on the spring. It's going to have a normal force. You worried about that? No, because on the box it's pushing up and it's going, that's negative work, right? Trying to slow the box down. And then on the springs, it's backwards, right? The box is pushing the same amount on the springs. That's positive work, right? Okay. So I'm not worried about the normal force. What about the collision? Well, thank goodness in this class, all of the springs are massless. Go down to, Home Depot and try to find a massless spring. But that's, hey, it's an undergraduate, it's a sophomore class, springs are massless. Suppose you were doing this for real and your job's on the line. Well, I would probably say, well, what kind of spring is that? I go look at it. Oh, man, that's about a 2-ounce spring. Okay, this guy's 2 kilograms. I'm going to ignore it. Okay? But if there's a life on the line, then I would probably do something else. Okay? So it depends on how critical it is. All right, in this class, springs are massless. So you don't have a mass hitting another mass, so there's not going to be any loss here. Okay? That's why I'm doing it, to point it out to you. Right? That's why he told you to ignore the mass of the plate before, and now he doesn't say that, because in the book he's saying all the springs are massless. Okay? That's why it's an energy. Okay, shall we do it? Okay. You got any energy going in or out? Nope? Okay, so 0 equals. It's not always 0. Be careful, right? Because I have done some problems where it wasn't 0. 0 equals. Okay, final. Okay, what is happening at the final? Well, the thing has hit the springs and it's gone all the way down and stopped. Right? Do you have any kinetic energy? Why not? Because he stopped. Right? So at the end, he has stopped. No kinetic. What about gravity? Depends on where you choose 0, right? Where would you like to choose 0?
Where he stops.
Okay, I'll do that. Is that okay with everybody? I was gonna pick it right here.
Yeah.
But whatever. We'll put it where it stops, okay? That was his idea. Okay, do you have any gravity energy at the end? No, because he's where he stops. What energy do you have from springs? Potential in the springs, right? How many springs you got? 2? Okay, so I'm going to add both energies in. So I have plus 1/2 Ka, watch the units. How much is A squished? Let's see, when they stop, it went down. Let's see, designed to arrest motion, S of 0.5, rest position. Okay, the springs are supposed to go down 0.2. Right now they're free, correct? Nothing's touching them. So 0.2, how much is the spring 8 squished? Is it less than 0.2?
Yeah, that's what I was looking for.
Did I say 3?
Yeah.
have to rewind it. I don't know 3. I don't know what the hell you're talking about. I see 1/2 Ka times squish squared. What's the squish?
0.2.
I would say it's 0.2. Oh, I said 3, not 3. It's 3 where it is right here.
Nice one.
How's that for recovery? Okay, that's the 3. That's where they are when they're free. So if they go down 0.2, what did they squish? They squished 0.2. Okay, so it's 0.2. Watch the units though.
I think we're okay on that. So 0.2 squared. Plus, I have some energy in the second spring, Kb, 0.2 squared. That's the final energy. Minus the initial energy. Okay, let's see. What's the initial energy?
Is the mass moving? Initially?
No.
No? Okay, no kinetic. Does he have any gravity? How much?
MGH, give me the H. Yeah, you do.
S is 0.5 plus 0.2. Why? Because that guy right there said he measured, right? Gravity he wanted at the final, right? So how high are you above it? 7.7. 0.5 plus 0.2. Does everybody see that? So it's 0.7. Watch the units. You have any spring energy? Initially, yeah, we'll do an initial. No? Okay, well then that's it. How many unknowns? 1. Kb. How many equations? 1. Piece of cake. Where are you going to screw up?